Welcome to our lecture video in Integral Calculus with the topic Integration of Rational Fractions. Now there are three subtopics under this, and the first one will be the distinct linear factors, and the two other subtopics will be discussed in the next videos. The simplest case is that in which the denominator can be broken up into real linear factors, none of which is repeated. In this case, the given factors may be rewritten provided the number is of lower degree than the denominator as a sum of fractions whose numerators are constants and whose respective denominators are the factors of the original denominator. Okay, so let's answer the sample problems to fully understand that description. Okay, for number 1, we have the integral of 2x plus 11 dx all over x squared plus x minus 6. Now it says there, the description, we need to rewrite. So we will rewrite this. So if we rewrite this, we have here 2x plus 11 all over the factor of the denominator, which is, if we factor this one out, becomes x plus 3. And then, so how do we factor this one out? So what we multiply here, so if we multiply here 3 and negative 2, if we add this, the answer will be the second term, which is 1. So that's back in algebra. So x minus 2. And then, according to the description, it is the sum of the, so this one here will become the sum of the fractions whose numerators are constants. So we will have numerators as constants. So let's have the numerator a plus b. And how about the denominator? It says there the denominator. So the denominators are the factors of the original denominator. So the factors of the original denominator are x plus 3 and x minus 2. So for A, we have here x plus 3, and then for B, we have x minus 2. So that's how we rewrite this equation. And then we will multiply both sides of the equation with the denominator. So the denominator is x plus 3, x minus 2. Here we have x plus 3, x minus 2. If we multiply this, the left side, what is left will be 2x plus 11 equals, if we multiply this with the first term here, the x plus 3 will be cancelled out, and what's left will be x minus 2. Then same happens with the second term. We multiply this with the second term, so the x minus 2 will be cancelled out, and what's left will be x plus 3. Okay, so for method 1, so what will happen here is that for method 1, so we have here 2x plus 11 is equal to, we distribute a, we have here ax minus 2a plus bx plus 3b. Then let's equate x. Let's take all terms with x. We have here 2x equals ax plus bx. So cancel x, we have here 2a plus b, then For b, we have 2 minus a. So this becomes the equation 1. Next, equate constants. So the constants here in this equation, we have there 11 equals negative 2a, then positive 3b. Substitute the value of b. 11 is equal to negative 2a plus 3 times for b, we have 2 minus a. So 11 is equal to negative 2a plus 6 minus 3a. Then we have here, what is 11 minus 6? That becomes 5 equals negative 2 minus 3. That is negative 5a. So a is equal to negative 1. So that's the value of a. Since we were able to find the value of a, therefore, we can have the value of b. So at b, or at 1, at equation 1, we have here b is equal to 2 minus a, or negative 1. So b is now equal to 3. Therefore, what will happen? We have here the original equation, 2x plus 11 dx all over x squared plus x minus 6 is equal to what we have here. We have rewritten this part. So we have a over x plus 3. So the value of a is negative 1. So negative integral of dx all over x plus 3. Remember that came from here. So we are looking for the value of a and b. And since we found a as negative 1, so we will now equate it, or we will integrate it with negative integral of dx plus dx all over x plus 3. Then plus, what's next is b over x minus 2. So we have here, value of b is 3. So the reason why I'm putting it here, because it's already a constant, so I can put it outside the integral sign. Over x minus 2. Then, this is actually, that is ln of x plus 3. Integral of dx over x plus 3, wherein if you derive this, the answer is dx. So, we have here ln x plus 3. Now, if you want to learn more on how to solve for logarithmic functions, integral for logarithmic functions, so watch the previous videos, x minus 2. And don't ever forget plus c. This may be correct, but without plus c, then the answer is wrong. To be cautious, sometimes, because some really do forget plus c here, it's best if you put the c on the prior to the answer, so that you're aware that you have put the c already. You can have it as c minus ln of x plus 3 plus 3 ln of x minus 2 if ever you forget plus c. Okay. Now for method number 2, let's see if we will be able to get the same answer using method 2. Now again, let's have this already, this part here. So 2x plus 11 is equal to a x minus 2 plus bx plus 3. So is it the same? Yes, it is the same. So what happens here in method 2 is that we can eliminate one of the unknowns. So we have two unknowns here. We have the a and b. We're looking for the value of a and b. We can remove the b here by substituting x with negative 3. That is to remove b. So substitute x with negative 3. So we have here 2 times negative 3 plus 11 is equal to a times negative 3 minus 2 plus b negative 3 plus 3, and this is already 0. So we have here negative 6 plus 11, that is equal to negative 5a. This is 5 is equal to negative 5a, therefore a is equal to negative 1. Same as what we got here in the method 1. Okay. Next, to have the value of of b, so what will we substitute with x? To remove a, what will we substitute for x? We will substitute x with negative 2 to remove a. So we have here 2 times negative 2 plus 11 is equal to a times negative 2 minus 2 plus b negative 2 plus 3, then cancel out here negative should be positive 2, sorry. So it should be positive 2. Substitute x with positive 2 so that we can remove a. So we have here 2 times 2 plus 11 is equal to a times 2 minus 2, so that will become 0. That's the right one. Plus b, we have here 2 minus 2, or 2 plus 3, sorry. It should be 2 plus 3. Okay, so we have here 4 plus 11, that will be 15, is equal to 2 plus 3, that will be 5b. b is now equal to 3. Same as what we got in the method 1. Therefore, we have here integral of 2x plus 11 dx all over x squared plus x minus 6 is equal to negative integral of dx all over x plus 3. Make sure that you're copying what you have rewritten here previously, because if you interchange these two, then the final answer becomes wrong. So make sure you're following the right sequence. So this is x plus 3 plus 3 integral of dx all over x over 2. And we can answer that using logarithmic functions. This becomes negative ln of x plus 3 plus 3 ln of x minus 2 plus c. Basically, we're just looking for the values of the constants a and b. That is what is being described here. The numerators, which are constants. So, as long as you know how to get the factor of the denominator, then it's okay. So that's for number 1. So screenshot first before we proceed to the next item. Now for number 2, we have here the integral of dx over x squared plus ax. It's obvious that a here is constant. So again, we need to rewrite. So we write this as 1. So we have here 1 all over x. If we factor out x, then we have here x plus a is equal to the constant numerator a over x plus constant numerator b over x plus a. Next step, multiply both sides of the equation with the factor of the denominator, x plus a. X plus a. Then cancel out with this one. What's left will be 1 is equal to, multiply this with the first term, cancel out x. So what's left will be a times x plus a plus b multiplied with the second term, cancel out x plus a. So what's left will be x. Then I prefer using the method B. Actually, it's much faster. For me, it's much faster, but it's still good to learn the method 1 so as to, if method 2 cannot be applied, then you still have the method 1. Okay, going back to this equation, how will we get the value of a? By removing b. How do we remove b? By substituting x with 0. So by substituting x with 0, we have here a times 0 plus a plus b times 0. So this is already 0. 1 is equal to a. Therefore, a is equal to 1 over small a. Next, for the value of b. So let's substitute x with, so what will we substitute x here so that the value, a can be removed, the big letter a. So x is equal to negative a. So we have here 1 is equal to a times negative a plus a plus b times negative a. So we have here 0. So 1 is equal to negative a b. Therefore, the value of b is equal to negative 1 over small a. So having the values of a and b, we can now go back to the original equation. So dx over x squared plus ax is equal to, value of a is the constant, we can put it outside the integral sign, 1 over a. Dx all over, remember that it is a over x. Then b is negative 1 over a, integral of dx over x plus a. Okay, let's integrate. So if we derive this, the answer is dx, logarithmic. If we derive this, the answer is again dx, logarithmic again. So that is equal to 1 over a ln of x minus 1 over a ln of x plus a plus c. So you can have this as the answer, or you can have it 1 over a ln of x minus ln of x plus a, or any other form just it can go back to this. Okay, so that's for number 2. Let's have number 3. Integral of 3t squared dt over t raised to 4 plus 5t squared plus 4. Now, let's get the factor of this denominator. So, we have here t raised to 4 plus 5t squared plus 4. So, if we multiply, what the numbers we multiply to have 4 here is 4 times 1. So that if we add this one, it becomes 5. So the factor of this becomes t squared plus 4 times t squared plus 1. So we write here. So we rewrite it as 3t squared all over, oops, let's move it here, all over t squared plus 4 t squared plus 1. That is equal to a all over t squared plus 4 plus b all over t squared plus 1. Then we multiply both sides of the equation with the denominator t squared plus 4 and t squared plus 1. So cancel this one out. So what's left becomes 3t squared is equal to a times t squared plus 1 plus b times t squared plus 4. Next, substitute t squared with what? So as to remove b, substitute t squared with negative 4. So we have here 3 times negative 4 is equal to a times negative 4 plus 1 plus b times negative 4 plus 4. So this is already 0. Then here we have negative 12 is equal to negative 3a. Therefore, a is equal to 4. Next, we need to find the value of b by removing a. To remove a, we substitute t squared with negative 1. So we have here 3 times negative 1 is equal to a times negative 1 plus 1 plus b times negative 1 plus 4. So cancel out here, so it becomes 0. So we have here negative 3 is equal to 3b, so positive 3b. Therefore, the value of b becomes negative 1. Therefore, integral of 3t squared dt all over t raised to 4 plus 5t squared plus 4 is equal to, so what we did here, so plus 4 and then plus 1. So that is equal to 4 integral of dt all over t squared plus 4. Then here the value of b is negative 1 dt over t squared plus 1. So can we use logarithmic function here? If we derive this, it will not give us the numerator. Therefore, we can use the inverse trigonometric function here, where u is equal to t and then a is equal to 2. Here, we have u is equal to t, then a is equal to 1. So watch the previous videos on trigonometric functions in order inverse trigonometric functions to refresh the solving for inverse trigonometric functions. So this becomes 4, then we have here 1 over a. 1 over a is 1/2 arctan u over a minus 1 over a arctan u over a plus c. So this becomes 2 arctan t over 2 minus arctan t plus c. So that's for number 3. Let's go to number 4. We have here number 4, integral of 3x squared plus 8x minus 12 dx all over x raised to 3 plus 7x squared plus 12x. You think this is more difficult than the previous one? The reason why it looks difficult is for the many numbers, for the many terms for the numerator and the power 3. Now, as long as you know how to factor out and having the knowledge of how to solve for this topic, then we're good to go. So we have here x raised to 3 plus 7x squared plus 12x. So we factor this one out. We have here x squared plus 7x plus 12. Then we can still factor out x. So what will we multiply here so that if we add it becomes 7? We have 4 times 3, and then 4 plus 3 is 7. So x plus 4, x plus 3. Rewrite. So this is rather longer than the previous ones. So 3x squared plus 8x minus 12 all over x plus 4, x plus 3. It is equal to a over x plus b all over x plus 4 plus c all over x plus 3. Then, multiply both sides of the equation with x plus 4, x plus 3. We will cancel out this one. So what's left is 3x squared plus 8x minus 12. That is equal to, multiply this with the first term. X will be cancelled out. So what's left is a times x plus 4, x plus 3 plus 4b. So multiply this with b, cancel out x plus 4. So what's left is bx, x plus 3. Now we have here c. For c, multiply this with the third term, then cancel out x plus 3. So what's left will be cx and then x plus 4. Okay, so it's kind of long, but it's actually fun to solve. Now to remove the b and c and only have a, what will we substitute for x? We substitute x with 0. So 3 0 squared plus 8 0 minus 12 is equal to a, 0 plus 4, 0 plus 3 plus b. Now here we can obviously see why we chose 0. Then c, so that's why we can now remove b and c. Then this one also 0, 0. What's left is negative 12 is equal to, what is 4 times 3? That is 12a. So a is now equal to negative 1. Next, we will need the value for b. So what will we substitute for x so that we can remove a and c? So what value of x will remove c and a? So we can have x is equal to negative 4. So 3 times negative 4 squared plus 8 negative 4 minus 12 is equal to a times negative 4 plus 4, negative 4 plus 3, plus b times negative 4, negative 4 plus 3, plus c, negative 4, negative 4 plus 4. Okay. So, as you can see, the value here will become 0. And then this one will become 0 also. So, no more a and c. So, what is 3 times negative 4 squared? That is 48. So, 16 times 3. Tama. So, that is negative 32 minus 12 is equal to this becomes negative 1 times negative 4, 4b. Therefore, 48 minus 32 minus 12, you have therefore is equal to 4b. b is equal to positive 1. Next, removing a and b so that we can have the value for c. So what will we multiply with, what will we substitute with x so that we can remove a and b? So substitute x is equal to negative 3. So we have here 3 times negative 3 squared plus 8 times negative 3 minus 12 is equal to a times negative 3 plus 4 times negative 3 plus 3 plus b times negative 3 plus 3 plus c negative 3 plus 4. So this already becomes 0 and also this one. So cancel out a and b. So what's left is c. So what is 3 squared? 9. 9 times 3, 27. Minus 24 minus 12 is equal to negative 3 plus 4, positive 1. Positive 1 times negative 3, that is negative 3c. 27 minus 24 minus 12 is negative 9, negative 3c. C is equal to positive 3. Okay, so we now have the values for A, B, and C. Therefore, from the original equation, we have 3x squared plus 8x minus 12 dx all over x raised to 3 plus 7x squared plus 12x is equal to the value of A, negative 1, integral of dx over x, value of B is positive 1, so we have there plus dx all over, what's that? X plus 4, then x plus 3 for C. So x plus 4, then for C, we have there positive 3 dx all over x plus 3. So finally, the final answer here is negative ln of x plus ln of x plus 4 plus 3 ln of x plus 3, don't forget plus c. So that's for number 4. Let's proceed to the last example, number 5. Okay, we're seeing some trigonometric functions here. So integral of 5 sine theta cosine theta d theta all over sine squared theta plus 3 sine theta minus 4. Factor out the denominator first. We have the denominator sine squared theta plus 3 sine theta minus 4. It's difficult if this is the first time you encounter this this format, but if you think of sine theta as x, then it won't be that difficult. So what will we multiply? What two numbers will we multiply here so that the answer is negative 4? But if we add, the answer is 3. So we have there 4 times negative 1 is equal to negative 4. But if we add this, the answer is positive 3. Therefore, the factor here is having sine theta as x. It becomes sine theta plus 4 sine theta minus 1. So we can rewrite now. So rewrite. We have here 5 sine theta cosine theta all over sine theta plus 4 sine theta minus 1 equals A all over the first factor. We have sine theta plus 4 plus B sine theta minus 1. Multiplied both sides of the equation with sine theta plus 4 and sine theta minus 1. Multiplying this, the first equation, term, we cancel out sine theta plus 4. What's left is sine theta minus 1. So we have here, cancel this one out already. So we have here 5 sine theta cosine theta is equal to A times sine theta minus 1 plus For b, multiply this with the second term. Cancel out sine theta minus 1. So what's left is sine theta plus 4. Again, what will we substitute with sine theta so as to remove b? If we substitute sine theta with negative 4, so we have 5 negative 4 cosine theta is equal to a negative 4 minus 1 plus b negative 4 plus 4. So this is already 0. So here we have negative 20 cosine theta is equal to negative 5a. So we have now a is equal to 4 cosine theta. So that's the value for a. Now how about for b? What will we substitute with sine theta so that we can remove a? So substitute sine theta with positive 1. So we have here 5 times 1 cosine theta is equal to a times 1 minus 1 plus b 1 plus 4. Cancel this one out because it becomes 0. So we have 5 cosine theta is equal to 5b. Therefore, b is equal to cosine theta. Therefore, we have here integral of 5 sine theta cosine theta d theta all over sine square theta plus 3 sine theta minus 4. So that is equal to, the value of a is 4 cosine theta. But I will just put out here 4, but cosine will remain inside here. Then sine theta plus 4. Next, for b, we have positive 1, then cosine theta d theta over sine theta minus 1. So how do we solve that? If we derive sine theta plus 4 here, the answer will be cosine theta. Same with the second term. Therefore, this is logarithmic function for ln of sine theta plus 4 plus ln of sine theta minus 1 plus c. So that's the final answer. So that's for number 5. Okay, that's all for this video.